Welcome to Chapter 1, Exploring Data. Let's see, you should have your packet in front of you. Okay, introduction. What is statistics? So statistics is the science of data. Data analysis is the process of organizing, summarizing, and asking questions about the data. So that is what we are going to do all year long. Organize, summarize, and ask questions about the data. Individuals are objects described by a set of data. Individuals may be people, animals, or things. A variable is any characteristic of an individual. A variable can take on different values for different individuals. So you may have one variable, you may have two variables, you may have multiple variables. Types of data. So we have two different types. So the first type is categorical. Categorical variables places an individual into several groups or categories, hence the name categorical. So some examples are gender, state, grade classification, so freshman, sophomore, etc. So they are words, okay? So clerical, you place individuals into groups of things. But quantitative deals with numbers. So a quantitative variable takes numerical values for which it makes sense to find an average. So examples would be height, weight, age. So quantitative are numbers. So you would take the height of someone, and that would be a number. You could find the average heights. Categorical, it doesn't work like that. You can't find the average gender. You can't find the average state because states are words. Even grade classification, you wouldn't take the average of those grades. So what is an example of using numbers to describe the values of categorical variables? So examples, so these are categorical, but you can't find, which means you can't find the average, but they are numbers. So usually you think quantitative is numbers, but these are numbers, but they're categorical, like zip code, area code, jersey number. It wouldn't make sense to find the average of those. What is an example of dividing the distribution of quantitative variable into categories? So let's look and see what that is. So an interval. So think about grades. A grade of an A is the interval of 100 to 90. A grade of B is 89 to A. C is 79 to 70, and D is 69 to 60. So you could take quantitative variables and turn them into categories by putting them as A, B, C, and D. Types of data. So AP exam tip. If you learn to distinguish categorical from quantitative variables now, it'll pay off big rewards later. You'll be expected to analyze categorical and quantitative variables correctly on the AP exam. The distribution of a variable tells us what values the variable takes and how often it takes these values. We're going to look at distribution of data a lot this year. So let's look at this information. So this is an example of US Census data. So it says it's from the 2000 census. So we always want to think about context. So context is, yes, I see a table of data. Well, what is it describing? So the context of this is given right here. Here's information about 10 randomly selected US residents from the 2000 census. That is the context. So we have data, all of this. So just take time to just look at it real quick. Okay, so the question is, who are the individuals in this data set? Well, who is this about? Who is this data about? Well, it's the context. It's US residents because it tells us right here in the context, US residents. Okay. What variables are measured? Identify each as categorical or quantitative. So you'll find the variables up on the top right here. So we've got to decide, are they categorical or quantitative? So categorical are state, gender, and marital status. Then quantitative are what's left: number of family members, age, total income, and travel time to work. So remember, the key to figuring out which one they are, does it make sense to find the average? Look at the number of family members. If I found the average number of family members, would that make sense? Look at age. Would you find the average age? Yes. Would you find the average income? Yes. Would you find the average time to work? Yes. That's how you determine which one it is. Does it make sense to find the average state or average gender or average marital status? You can't find the average because those aren't numbers. Okay, let's go to the next question. Describe the individual in the first row. So let's look at the first row. Kentucky, 2, 61, female, married, 21,020. So we couldn't just put a star by this or just repeat it. We have to write it in words. So there's many different ways to write this. Here's one way. The U.S. resident in the first row is a 61-year-old married female who lives in Kentucky with 2 family members. She makes an income of $21,000 and travels 20 minutes to work. So what you're going to find in AP Stats is that we need to write answers in sentences. We are not just writing words and hoping that the reader of your exam is going to understand what you're saying. We have to act like the person reading or grading your exam knows nothing. So you've got to put it all out there in words and make it make sense. So let's start with 1.1, analyzing categorical data. So a data table is raw data for each individual. So nothing has been done to the data, it's raw. It is just directly from wherever you got the information. So let's say it's a survey or an interview or some kind of poll. It's just raw data. A frequency table displays counts, which are frequencies for each variable. And we're going to see these things. Relative frequency table displays percents. So frequency table and relative frequency table are connected, and a lot of times you'll kind of see them together. Relative means in relation to others. So when you look at percents, you can compare. You can say, okay, 75% chose this, 10% chose that, 15% chose this. So you're able to compare. When is it better to use relative frequency? When you want to compare distributions of multiple variables. Just like I was saying, whenever you compare percents, you can see how they relate to each other. You can compare them a whole lot easier. So if I say females is 100, males is 150, those are different totals. But to see them as percents makes it much easier to compare. Okay, frequency table versus relative frequency table. Let's say we surveyed 20 students about their favorite fruit, and here are the results. Okay, so we have, you don't have to write this down, we're just going to compare. We have apple 8, banana 5, orange 4, grape 3. So we're going to take this frequency table and turn it into a relative frequency table. So 0.40, 0.25, 0.20, 0.15. And so these are in relation to others because it's added to 1, which is 100%. So you can always change from decimal to percent by moving your decimal 2 places. Bar chart versus pie chart. So back in elementary, middle school, we used bar charts and pie charts. A lot of times We loved pie charts. A lot of teachers love those. So let's talk more about that, because now we're not in elementary anymore. We're in AP Stats. So we want to make sure that we have proper labeling. And actually, with a bar chart, it's easier to compare than a pie chart. Yeah, we can look and see, okay, which one has the bigger piece of the pie? But a bar chart, you can just look horizontally to see how they compare. So when is it inappropriate to use a pie chart? When each percent refers to a different category. So not all the parts of a single whole, which causes the total to be greater than 100%. Usually with pie charts, you should add up to 100%. So if you're not looking at one whole, then you may have greater than 100%. So just be aware of that. All right, so here's the example of bar chart versus pie chart. So we have the bar chart as a relative frequency, and then we have the pie chart as percents. So it's kind of hard to see on that pie chart. I mean, it's good that the percents are there, and so you can compare it better. But that relative frequency bar chart is so much easier to compare. You can see apple is so much more. It's actually double of what orange is. Whenever you just look at the pie chart, without those percents, you wouldn't know that it's double. Okay, so something else you need to be aware of with statistics is misleading graphs. There are misleading graphs all the time in media. So we need to be smart. We need to be able to identify, does this graph make sense? So let's look at this pictograph. So yeah, it's real cute, but does it make sense? So look at the different ice creams. So what I noticed right off the bat is chocolate is 22%, others 53%, but they have the same number of scoops. So does that make sense? Not really. So I don't know why the author of this pictochart would choose to do that. It's very misleading. Let's look at another one. Issues with vertical axis not starting at 0. So let's look at our vertical axis. So see how it starts at 20, 30, 40, 50, and 60. And so then when we compare, does this at all make sense? We're missing quite a bit down here to really make sense of the data. So whenever you're looking at a graph, make sure that you look at that vertical axis. Okay, violating the area principle. So states with most high school athletes. All right, real cute, right? Well, look at these balls. Look at how they compare, okay? So the basketball looks about the same size as the football. It actually looks bigger. So that doesn't really make sense with this. And then this, I just don't understand why they would use the different sizes. So that's violating the area principle. Okay, misleading graphs. So like I was talking about a minute ago with the pie chart being greater than 100%. So pet ownership by type. So let's look, dogs 50. Is that even half of the pie? No. Birds 30%. Cats 40%. This doesn't make sense. So just make sure that you're using some common sense here. Okay, let's look at a two-way table. So this may be new to us. So a table that describes the relationship between two categories. So here is the example that you're given. Types of phones and ages. So we have iPhone, Android, and other. And then we have the ages. So the reason it's a two-way is because this variable is talking about one thing, so types of phones. This is talking about, this is an interval of ages. So we're supposed to compare and see if there's a relationship between types of phones and ages. Okay, so the example, here's our context. The Pew Research Center asked a random sample of 2024 adult cell phone owners from the US which type of cell phones they own. Here are the results broken down by age category. So they surveyed 2024 adult cell phone owners, and then they broke it down by age and by type of cell phone. The marginal distribution of one of the categorical variables in a two-way table of counts is the distribution of values of that variable among all individuals described by the table. So we are going to see is there a relationship. So we are going to calculate the marginal distribution in percents of type of cell phone. Make a graph to display and describe what you see. Okay, so we're going to start out with iPhone. So iPhone, there are a total of 476 people who were surveyed out of the total 2024, which gives us 23.1% had iPhone. Android, do the same thing, find out total Android. So we're not even looking at age right now. We're only looking at type of phone. And then we have other, 1,054 out of 2024. And we're putting those as percents. Okay, so we're going to take that data and put it as a bar chart so we can compare it. So I use Google Sheets to do this. And throughout the year, I'll show you different ways of making graphs with technology. But right now, you'll just draw this. So you need to pause it, you can. So notice that it starts out at 0. So we make sure it's not a misleading graph and it goes up by the same amount. We leave space in between whenever we do a bar chart. We're going to have another kind of chart that you will not leave space unless there's space in the data. All right, let's look at conditional distributions. A conditional distribution of a variable describes the values of the variable among individuals who have a specific value of another variable. So conditional. So we're talking about the age and the type of phone. So see how it says a specific value of another variable? So there's a separate conditional distribution for each value of the other variable. So how do we know which variable to condition on? So we are going to think, do you think age determines type of phone or type of phone determines age? So we could do it either way, but which one makes more sense? So the way we determine this is explanatory versus response, kind of like X and Y whenever you do input and output. Does age predict type of phone or does type of phone predict age? What I'm going to go with on this, because it makes more sense to me, is age is the explanatory variable. So that's the one we're going to condition on. Okay, so we're going to calculate the conditional distribution of cell phones for 18 to 34-year-olds. So we're going to look at this column and then look at each of these rows. So it's going to be out of 517 where we find our percents. So iPhone, out of 18 to 34-year-olds, 169. And that's 32.7%. Android, 214 out of the 517, which is 41.4%. And other, 134 out of 517, 25.9%. Okay, we also need to do the others. And the reason we want to do the others is to see if there's a relationship. So you can pause it and go ahead and find each of those percents and then come back and check your work. Okay, here are iPhone, Android, and other for the 35 to 54-year-olds. Then 55 and up, there's iPhone, Android, and other. So we have all the data. We took the raw data from the table, and then we found percents. So now we need to put it on a segmented bar graph. This is what a segmented bar graph looks like. So this is all 18 to 34-year-olds. See how it goes up to 100%? So blue represents iPhone. So iPhone was 169 out of 517. So iPhone was 169 out of 517. We found that was what? 169 out of 517, 32.7. So see how it goes right here, a little bit over 25. And you can number these however you want. Just make sure you go 0 to 100. And then the next is Android, and then other. And then here's the other two age groups. So we are looking to see if there's some kind of association. Does age predict the type of phone that they own? There is going to be some kind of association because these aren't all the same. They're pretty different, right? So if they're different, there's some kind of association. So let's answer the questions. We say there is an association between two variables if knowing the value of one variable helps to predict the value of the other. So knowing their age, does that predict or help us predict what kind of phone they have? I think we can take a pretty good guess. If knowing the value of one variable does not help you predict the value of the other, there's no association between the variables. So we did association back in middle school and in algebra. So we're kind of looking at the same, seeing does one help predict the other. So how can you tell by looking at a graph? So remember that segmented graph? If the segments within each bar differ, then there's an association. So the segments within each bar will differ when there is an association. So if all the bars look the exact same, there's no association. If the segments within the bars are different, then there will be some sort of association. Drawing conclusions that go beyond the data is called making an inference. So it helps us describe the data and predict for future. Okay, so here's our segmented bar graph that we drew earlier. So explain what it would mean if there was no association between age and cell phone types. So hopefully you remember we just talked about this. No association would mean that knowing the age of the person does not tell us anything about which phone they prefer. And the bars would all look the exact same. Based on this data, can we conclude there's an association between age and cell phone type? Are the bars different? Yes. So based on the data, so we are going to, really explain this. We're not just going to answer this yes and no. We have to explain so that the reader understands what you're saying. The reader is going to pretend like they know nothing. And so you've got to be really specific and also include context. What is this about? So based on the data, 18 to 34 and 35 to 54-year-olds prefer iPhone. So look at these two, prefer iPhone. And Android, with more than 50% owning these. So if we look at this, this goes almost to 75, and this one goes, maybe 55? Meanwhile, much less than 50%. Whoa, look at these, 55 and up. So they do not prefer iPhone or Android. So meanwhile, much less than 50% of 55 and up prefer the iPhone and Android option. So if I say, hey, somebody who's 25, do you think they're going to have an iPhone or Android? What would you say? Most likely, yes. If you said, okay, somebody's 60 years old, what kind of phone do you think they have? You're going to say, probably not an iPhone or Android. All right, so that is it for today. So I will see you in class.